So, clearly playing from my office because I'm between labs right now. Let me know if you can't really hear that much, but this is going to be different because I don't have a whiteboard behind me to work on, but I've got split screen, which is really, really nice. So, what questions have y'all got for me today? No questions? I highly doubt that. So, during the pandemic, I had to pick up things to keep me intellectually stimulated because even though I've been working on developing the organic shells, developing the organic curriculum, that can be the only part of your mind you work with. And it's kind of interesting doing the Tuesday, Thursday stuff because I'm here and it's really just me and like one or two other people. And honestly, I feel kind of bad for the people in the building right now because I'm trying to learn the fiddle. So this is like my third or fourth day playing the fiddle. It is the absolute death of music, and I know that thing's got to be carrying through this building. So if you ever show up or you ever leave the morning labs and you hear like this blood curdling sound coming out of SC, that's probably my fiddling playing for the first couple of months. But I bring this up because I've been trying to like figure out what to do during live streams when there's like no questions, because I don't want to like sit here and awkwardly stare at a computer or have you like awkwardly sit there and like people who are live streaming or people watching the old live streams having to like sit through hours of me staring at the screen because that's where the camera is. So probably what I'm considering is there are a few instruments I'm trying to remaster the guitar. I played it a lot before, kind of fallen in and out, so now I'm going to go back and like relearn the fundamentals. I've got the banjo and then I've got the fiddle. So if I don't see questions in the chat menu, probably what I will do for some of the live streams is just mute the audio and work on some exercises so I'm still here to answer the questions. But for those of you who are like watching the video and trying to figure out when I actually start answering questions, when the instrument gets put down, that means that somebody actually like asked a question. So I see 3 concurrent viewers on my other screen. If y'all have questions, go ahead to ask them. Otherwise, I don't really have that much work to do today. I don't really have anything much to say other than go ahead, work on the discussion boards, make sure that you're keeping up on the homework, and again, feel free to email me questions or show up to these live streams and ask questions. Yeah, I'm going to loosen the bow so I can like back up the fiddle. Still got the training wheels on too because I gotta have all the notes tapped out. Though I'm getting better. I can put my fingers there consistently now. This is my new toy. So again, I'm just going to kind of mess around. Again, I don't want you to have to deal with me like awkwardly staring at the screen. So if you've got questions, answer them. I've got the chat menu up on the right. Otherwise, I'm going to mute the volume so you don't have to listen to me mess around with it. But yeah, just feel free to ask any questions you have. So one student says they have a question, but they'll be right back. So I'll just kind of keep the audio going. These are just chord warm-ups, so shouldn't be that bad. And then when he gets back, I'll answer his question. I would like to assume for the concurrent viewers watching that this is actually just kind of like background music for you at this point. I assure you I know more than chord exercises. I'm just trying to get back to basics of starting with the chord exercises and working my way up to more complicated styles. Not that fast. Practicing the banjo a lot more, which doesn't require as much fingering. I can tell I've lost my calluses because of the banjo. But the trade-off is the banjo's a lot faster. So with the guitar you strum, but with the banjo you pick. Explaining how to do number 8 in the lab manual homework that is due on Tuesday. So, I guess to a real question. So the question in the lab manual asks if you have a compound that is RRRR. So there are 4 R's in the compound. It doesn't I think it specifies what the compound is. So it's this nightmarish compound. Actually, I've got it saved. Hold on. Let me go to the course website. Just a minute. So the compound is RRRR, so there are 4 R centers associated with it. Now this solution key is going to be available to you next week. I'm not posting it to the course website quite yet because I'm worried people will just copy and paste it instead of like looking through it. So this bottom thing here, this is the compound. This is one of the stereo projections of the compound it's given you. So there's a lot going on here, but what the 4 R's imply is that there are 4 chiral centers. So as we covered in lab this week for Orgo 1, a chiral atom has 4 different things bound to it, and a chiral atom will have a mirror image of it to give you the enantiomer if you have a single chiral center. So by saying there are 4 R carbons on this molecule, you are saying that there are 4 chiral centers. So the different combinations that you can create are basically variations of R's and S's. So I'll show you. For example, you have your 4 R's. Well, by definition, the enantiomer has all the chiral centers flipped. So the enantiomer of the RRRR is the SSSS. Now, for every chiral center you have the potential of 2 enantiomers. And so this is where the lab manual talks about the power roll 2 to the n. If you have 4 chiral centers, you have 2 to the 4 possibilities of different stereoisomers. So in this case, you'll have 2, 4, 8, 16 possibilities. So you need to work out what all 16 possibilities are. So like RRRR, RRRS, RRSR, RRSS, RRRSRR, and so forth, and then figure out which of those are enantiomers. Now, if they're not enantiomers to each other, then they're a diastereomer. The last portion of the discussion board. So let me pop over to collaboration. And my end's going to show a lot more on your end. So the last part, for each chiral center, give the chirality RS. The carbons have been numbered to help you with the assignment. So really, when you work it out, there's only 3 chiral centers here, 2, 3, and 4. And in this case, this happens to be one where the wedges tell you that it's a chiral center. Actually, no, it's not. 2 is not a chiral center, and this is by design, because if you look at it, 2 is connected to 2 methyl groups. So, I knew this was a good question. Also thought it was weird I would not have a number of points divisible by 3. So let me build the molecule for you really quick. Oops. So we've got the backbone, and if I build it the way it's drawn, I've got the 3 methyl groups coming at you. So methyl group 1, 2, and 3. So carbon 2, carbon 3, and carbon 4. Now, when I go to do the Fischer projection, what I'm going to do is I'm going to turn this so this way it ends up becoming a loop. So when I draw the Fischer projection, and I'm probably going to have to use paint for this. Oh well. Don't have that option on this computer. Learning so much today. So if I were to draw the Fischer projection of that molecule, and I'll show you the end result. I would start by drawing a vertical line, and I'd have my two groups, the CH3, the CH3, and as I take my modeling kit, this is intentionally set up so this way the two hydrogens finish on the end. So I start working my way down. I have the starting carbon. The next one's going to have the CH3 group on the left side. The next one's going to have the CH3 group on the right side. Come on. Next one's going to have the CH3 group on the other side, so it's going to be back on the left side again. The next one has two hydrogens. So that's part of why I asked you for the Fisher projection in the first question. So this ends up being your Fisher projection when you get done drawing it. Now, what you'll notice and I'll write the numbers beside them. 1, 2, 3, 4, 5, 6. Carbon 2 has two methyl groups on it. So it's got this top missed my whiteboard already. It's got two methyl groups on it. So carbon 2 is not chiral. Carbon 1 is not chiral because it's got more than one hydrogen attached to it. Carbon 5 is achiral because it doesn't have any hydrogens attached to it. And the final carbon 6 doesn't have any hydrogens attached to it. It's only carbons 3 and 4 that actually have different groups attached to them, so they are actually chiral. Now, in terms of figuring out their chirality, we have to do the prioritization. So for carbon 3, hydrogen's going to be the lowest. That's going to be number 4. In terms of what comes next, we're going to have to look at what's bound to it. And I actually had a student today that asked a question which kind of helped me find a better way to explain this. When we use the Kohn-Ingold priority rules, what we're doing is we're not looking at the whole molecule. We're looking at the atoms that are next to the chiral atom we're dealing with. So let's say I do carbon number 3. And carbon number 3 is this one here. Come on. I'll put a white hydrogen on it to make it a little bit easier. So we have a hydrogen. Try doing it. Hydrogen. It's bound to a carbon, and there's a carbon above and below it in the chain. So this is what's immediately around that chiral carbon. So we're going to rank these priorities as best we can. Now, carbon outranks hydrogen, so hydrogen is going to be the number 4 priority. Now we have to look at what's bound to those carbons. So if we go the next step out, the carbon above it has a hydrogen and 2 carbons bound to it. And the carbon beneath it, so if we go the other way, has 2 carbons and a hydrogen bound to it. So again, we don't, and if we, I'm sorry, we missed the 3rd carbon. The carbon beside it has 2 hydrogens bound to it. Sorry, confusing myself. So, if we look at what comes next, this carbon here only has hydrogens. The other ones actually have 2 carbons bound to them. So this methyl group here is going to be lower priority than the other 2 chains. So this will end up being, sorry, the hydrogen is number 4. So the methyl group ends up being number 3. Now, if we look at the next carbon out, we see that the top carbon has 3 hydrogens bound to it, and the bottom carbon has a carbon and 2 hydrogens bound to it. So because of that, the bottom carbon is higher priority, which makes it number 2. And that other group, I'm sorry, makes it number 1, makes the other group number 2. And I know this is kind of hard to see with me like doing pencil and paper drawings here. So what we're going to do with that information now is we've got our chiral carbon, we got carbon number 3, and we're going to turn it to the screen so that this hydrogen is kind of is eclipsed by, come on, So this carbon is eclipsing the hydrogen behind it. And we're going to count the priorities. So the methyl group is the lowest priority, and this longer chain here is the higher priority. So that's 1, 2, 3. So 1, 2, 3. And I'm going to have to look at it from my end. 1. Something's not right. Shoot. Sorry, Elijah. Let me try that one more time. So let's start with what we started with before. We've got our chiral carbon. We look what's immediately bound to it. So carbon number 3 in the figure. So hydrogen is going to be the lowest priority because it's outranked by carbon, but the 3 carbons at this point look equivalent. So we're going to make that hydrogen number 4. Now we look at what's bound to each carbon. So the carbon in the figure to the left, which is going to be the top carbon here, has 2 carbons and a hydrogen bound to it. The carbon beneath it, or God, why am I confusing myself so hard with this? It is a good problem. So the carbon after it has 2 carbons and a hydrogen. And since this one is surrounded by hydrogens, these two have the same groups around them. This ends up being the lower priority because it's got less heavy atoms bound to it. So this ends up being our number 3. Now, when it comes to the carbons that follow afterwards, so we keep working our way down the chain, these are all terminal carbons, so they finish up in hydrogens. Whereas our bottom carbon still has more carbons attached to it. So because this terminates and this one keeps going, that bit to the right ends up taking higher priority, so it ends up being number 1. And the chain to the left ends up being number 2. Now, build our model, turn it so this way our hydrogen is behind us, and what we see is that we have highest priority is down here, so this is number 1, number 2, and number 3. So if we look at that rotation, 1, 2, 3, that's counterclockwise, so that ends up being S symmetry. When you go to carbon 4, it's the same argument. Now, the nice thing about alkane chains, so there's no like atoms attached to it other than carbon and hydrogen, it's going to relate much more to molecular weight. So if you're curious what the higher priority group is for just an alkane, and I'm going to tell you this, just only do this for alkanes, don't do it for anything else. The bigger chunk of the chain that is larger and bigger, is going to be your higher priority carbon chain, generally speaking. So I don't know if that really answered your question, but yeah, this is kind of the one that's up there, the R and the S for the 3 and 4 carbons is kind of on the hard end. But it's going to take that approach where you just keep working your way out with the Cahn-Ingold-Prelog rules until you see a difference in the carbon chain. So for carbon 3, if we look at carbon 2 and carbon 4, they look exactly the same. So we actually need to move out to carbon 1 and carbon 5 and see if carbon 1 or carbon 5 take higher priority. Sorry, that kind of prattled on there for a minute. Did that answer your question? Hopefully. Yeah, it's also hard to translate it. So let me try to help you one more time with that priority rule for the R and the S. So let me bring it back over to the example. So carbon 3 is chiral, and there's a hydrogen in on there, that hydrogen is going to inherently be the lowest priority. So the question is, of the carbons around it, which one's lower priority? Well, we're going to look at the one that at this point has heavier weight stuff bound to it. So this carbon has 2 carbons bound to it. This one has 2 carbons bound to it. This one doesn't have any carbons bound to it. It's only hydrogens. So that methyl group there is going to be number 2. Is going to be the second. Is going to be the second lowest priority. Now, carbon 2 and carbon 4, they look exactly the same. So they can't possibly have different priorities. So now we need to move further out. So now we're going to compare carbon 1 and carbon 5. Carbon 1 has 3 hydrogens, carbon 5 has 1 carbon bound to it, so it's going to be a higher priority. So then our priority highest is going to be the branch that contains carbon 5, so this right one. The second highest will be this one that contains carbon 1 and 2, that'll be number 2. Next lowest will be the methyl group, and then the lowest will be the hydrogen. So when we go to rearrange, when we take our molecule and we actually look at it, this will be 1, 2, and 3. Now, the nice thing about the way this is drawn, the hydrogen is inherently going back, so we can kind of do it with the screen. So we have 1, 2, 3. Since we have counterclockwise rotation, this will end up being S. And if we look at 4, it's going to be the same argument. Yep, carbon 4. Let's see here. 1, 2, 3. It's also going to be S. Cahn-Ingold-Prelog rules also get a lot easier when you have heteroatoms on here. They get hard for alkanes that are just pure alkanes, simply because you have to start packing the chain further and further out. But if this had like an alcohol on it, it'd be really easy to figure out pretty fast who the priority is. Other questions? Nope. The nice thing about the discussion board is you can always resubmit your answers too. So if you get it wrong, that's fine. I'll tell you, hey, that's not the correct symmetry. Go back and you can do it again. So don't be afraid on these discussion boards to get it wrong. It tells me a lot if you get it wrong, because it gives me a feel for where you're not understanding. Because you can always like just happen to get it right. But yeah, the discussion boards are meant to be low weight. They're ultimately going to contribute towards your homework, but again, feel free to do them. If they're incorrect, you've got other people's work to look at and try to figure out yourself. All right. So glad I could answer your questions today, Elijah. Let's see if there's anyone out there. Looks like there's one other concurrent viewer. Yeah, I'll definitely see you next Tuesday. If not on the live streams tomorrow or next week. Yeah, for the discussion boards you post, and they are just discussion boards. You just can always post more and more. And generally what you'll see is I'll post a grade. If it's not 100%, you should see a comment, a little bubble in your grade that will display my comments. And I'll explain like, oh, this number's not right, this number's not right. And generally I'll lead, especially if I know people have already posted to the discussion board, I'll tell you to go consult their discussion boards and see what they got. And usually that can kind of help you like self-teach. But also just check my comments anyway. Sometimes I'll make a comment saying you got it right, but your reasoning wasn't quite there. But yeah, you're always allowed to resubmit your answers for the discussion boards. Especially if you have a week where you're like, because the discussion boards also count towards your attendance. So if you're not able to get to the discussion board, you do need to post something so I can say that you attended class that week. And you're always free to say, hey, I couldn't do the discussion board this week. I'm just getting the post to get my attendance in. That's fine. I would rather you work on the discussion board when you have the time to really commit to it. Now, don't do that to me every week, but definitely if you're having a week where you're just too swamped, post something so I've got your attendance grade, and you can always come back and re-answer it later. right, I'll give it a couple more minutes. If there's no more questions, then we'll sign off. Not gonna forget you this week. Drat. All right, there are no other questions. We'll sign off. I will see some of you in the live stream tomorrow, and if not, I'll definitely see you in labs next week. Thanks for showing up.